Okay guys, so in this video what I'm going to do is go over the Java serialization, specifically on the exploiting out for a SQL injection side. The lab indicates that you already have a low privilege account, so obviously the intention would be to get a high privilege account, i.e. administrator access. So if I copy this into my browser, again just logging in. So I'm logged in. If I have a quick look at the request that was sent, I can see if I send it to repeater, make it easily available to read, but you can see here, I'll just make it a bit bigger, I'm sending over still something that's base 64. So if I decode it, I can see that I'm actually sending over, as part of my session token, a serialized Java object called access token user. So this kind of gives us an understanding of what actually happens in the background. But obviously if I go into a discover contents and then start running that, one hidden gem in the background is actually a Java file, an uncompiled Java file, as well as the access token user that's also available. So if I go into repeater, send this as well to the repeater side. These are the two, so that's the original one. But one thing to note as well, you don't have to run the contents to discover it. It's actually remmed out in the HTML side. So either option gives that visibility, but essentially if I run this, it gives us some idea what's going on in the background. So I'm actually creating a serialized access token instance and sending that over in the request. Here, example, this is another serialized object that we don't actually know what's being used for, but there is a predefined query in here. You can see it's actually a Postgres query where it sends over the ID. So one would hope that we can try and send this as a base 64 serialized object as a session, cookie session, in the hope that we'll be able to exploit that SQL injection. So I've already put this in my ID, and I'll make it clearer. It's very difficult to read from the response, but you can see here I'm just grabbing the ID. This is really here because it's referenced within the Java the product template. But essentially what I'm going to do is create an instance of this product template and sending what is called the ID, passing that variable to the template as part of the instantiation, and then I'm just calling a custom method that I've used. The get call I've created for the purpose of speeding up the process, but essentially what I'm just doing, you can see from line 28 onwards, when it's called, I'm actually just getting a base 64 version of that serialized object. So if I do a request, one thing to note, just make it easier to read, I'm actually getting a Java casting exception. So it's saying that the product template that I've sent over cannot be casted into the same form as the access user token. So, not that it really matters. What I can do is try and send over the UID and try and get some further syntax errors. So again, just make sure I grab the whole thing. And this process is a little bit arduous, hence why we'll see in a bit how to speed up the process. But you can see here I actually get a syntax error that for the user ID, just some jargon nonsense for a Postgres SQL. So we already knew that it was Postgres because we saw it in a predefined statement. But what we're essentially doing is sending over an incorrect syntax that is able to give us some information about what's happening from the SQL response. So one thing to note as well is that we knew that it's Postgres, but there are different types of syntaxes based on the SQL databases. So we know that this is Postgres. So I can put in a correct syntax. The URL here, I've actually just grabbed it from the lab, and I'm calling this to speed up the process. I don't want to copy and paste the whole time, so I'm using the serialize as I mentioned, just putting it in a serialized base64, but then sending it to a custom method that I've just created. This again, I've just copied the method along with the cookie. I don't think anything else is really needed. I grabbed this from Stack Overflow, wherever it is. Any of these would work, but yeah, you can see here I'm just setting the method, sending it a request, and I'm just looking for the response. So you'll see why in a bit. Actually, if I just run this, I don't have to compile and copy the code, but if I do on line 23, I'm actually getting the response, the same response I was getting in Burp. You can see here I'm still sending over the user ID. So again, just making sure it looks pretty up front on the screen. Let's make it a little bit bigger. The reason why I'm doing this is obviously it makes it easier to run, speeds up the process. Yeah, so every time I run this, it should work as expected. So give it a save, Control 11 or just pressing the button will evidently work. But you can see I'm getting a syntax error here because I'm adding a new query, just obviously adding in the union aspect. But here you can obviously see that because the syntax error is incorrect, I'm actually getting a union error saying that the columns I've sent over is not correct. So again, once we know the database architecture, we need to find out how many columns there are. So again, quick copy and paste. Still the same error. So it's 4, 5, 6. Still going. Here. So this is the error that we were getting initially, which means that the syntax that we're sending over the correct syntax, which is 8 columns that we know is the other query or the other table object that we're trying to get information from. So once we know that, once we know the database architecture, once we know how many columns we're getting, we need to know the schema. And so Oracle's a little bit different. Again, the 4 main ones, but I know that the Postgres is the information schema. So now that we have the right number of columns returning, again, just give this a save. So run that one out and make this a bit easier to read as well. So I'm just going to change the query again from information schema. First thing we want to do is find out which tables is being used. So hopefully that runs. Yeah, so we're getting a correct syntax. If I put in a bad syntax, it'll obviously say the table doesn't exist. So we know this table exists. Next thing we need to do is find out a column that is a type of column that we can try and exploit. So what I'm going to do is try and get the table name, which is a column in the information schema.tables, I'm trying to make it into a numeric. Again, just trying to throw errors onto it. Information seems okay. Yeah, so that didn't work, so we'll try another column. Yeah, try 8 columns. Got syntax, another syntax. I wonder if something's wrong with the code. Yeah, syntax error. Oh, I know. Yeah, I haven't put the comma separating the columns. Okay, so let's just try it again. So that's a syntax error. So grab that with the column. Try column number 2. Same concept. Let's try this one. Same error. Here, this one looks a little bit different. So actually, you can see here the input syntax is coming back as users. So we know that the table name, because we're looking at information schema.tables, we know that the table that is being used is called users. Once you know the information schema, then you need to know which type of columns are being used. So instead of information schema.tables, it's information schema.columns, and obviously where the column name, where the table name is users. Same concept. And different error. Okay, yeah. So because we were looking at tables in the past, we need to look at column in this case. No need to change the formatting or which column, but you can see here the username is the column name that is being used as part of the other query. So let's just make a note on there being the username. So again, new query. So I'm just going to remove. So remove that, but put in the username, and we know which column and which table we're looking at. So again, we just need to search from users. No single quotes. I'll give that a run. Okay. So here, I'm actually getting back the username being administrators. So okay, just make a quick note here. Same query. So where username equals administrator. Okay, so we've got the table, we've got the column, we've got the user. We need to find out if the password is stored in here. Now this is a little bit of a difficult one because the password is typically structured. But if I just give it some jargon, it will say the column doesn't exist. But if I try and put in, like passwords, it actually says it doesn't exist, but there is a users.password instead. So that's the one that we need. So you can put in users.password. Again, getting a response being, one would assume, the administrator's password. So log out, go to my account. Administrator, and then the password that we have. Yeah, so admin console, delete. Problem solved. Nice and easy one. Alright guys, thanks for watching.